Hi everyone, thanks for attending my presentation. This is John. I'm from Amazon Alexa AI, and today I'm gonna present my work called Paraphrase Label Alignment for Voice Application Retrieval in Spoken Language Understanding. So before we jump into the model details, let me introduce the background a little bit. So Alexa systems responds to user requests by routing to related art applications. So the user request, we call it utterance. They are in Alexa, and Alexa handles the utterances and suggest and invoke the related application to handle the utterance. And there are two sets of the skills in Alexa systems. One is called the first-party skill, also called domain, includes all Alexa developed skills, such as calendar and news, etc. And another set of skills are third-party skills, include all non-Alexa developed skills, such as Uber and Lyft. So there's an example shown here about how Alexa handles the user utterances. Given utterance like Alexa, play today's hits, Alexa will find out the best suitable application in the device, and for example, Pandora, and then Pandora will be invoked and play the music. And back to our research question in this paper, our goal is to avoid unnecessary utterance failures in spoken language understanding systems, such as model incapability or routing errors. We propose a skill retrieval systems as a downstream service to suggest the fallback skills to unclaimed utterances. So what's the meaning of the goal? So we can take a look at the figure shown below. The figure below shows the overall pipeline in Alexa. After the user issue a utterance like play today's hit, the device will first pass to the ASR module, the audio speech recognition module, to convert the audio to text. And then it will pass to the NLU module, the natural language understanding module, including three parts: the domain classifier, the intent classifier, and the slot type for the NER. And then it will decide whether this utterance is claimed or not. If there is a claim, if the utterance is claimed, meaning that there will be a suitable skill to handle this utterance, and then the skill will be launched. If it's not unclaimed, meaning that there's no suitable utterance, suitable skills for that in our previous pipeline in Alexa, those unclaimed utterances will be directly sent back to the users by saying that, oh, sorry, we cannot understand. But in this paper, we propose a PLA model, the Paraphrase Label Alignment model, which leverage those claimed utterances and trying to find some fallback skills to handle those unclaimed utterances. Because this, as we mentioned before, those unclaimed utterances are caused maybe by the NLU module incapability or some routing errors. Those unclaimed utterances might still be in a good quality to assign some appropriate skills. And then passing the PLA model, we will suggest the best suitable fallback skills and ask whether the customer is satisfied or not. If the customer is satisfied, we will therefore launch the skill. Otherwise, we will still return saying that, sorry, we cannot handle it. So the method for the skill fallback skill recommendation is a two-step approach, including a paraphrase detection and a skill retrieval. The paraphrase detection detects the paraphrases from the unclaimed utterances. Those unclaimed utterances are associated with launched skills, and they can give us more information from the content side and as a data augmentation. And the skill retrieval model is to retrieve skills via a customized loss function, aligning paraphrase launched skills. So the pseudocode showed in the red part, showing the two-step details. The paraphrase detection step, it contains two parts of the similarity calculation. We will explain in the next slides. And skill retrieval, including a shortlister and a re-ranking, shortlisting and a re-ranking stage. We'll also explain the details in the next couple of slides. And in the testing stage, we only apply the skill retrieval step on unclaimed utterances to predict the relevancy labels of their shortlisting skills and retrieve the most appropriate skills. The claimed utterances are not involved for the testing stage. It's only used for the model training to provide some auxiliary labels. So let's take a look at the paraphrase detection first. It contains two steps containing the role selection and the pairwise matching. So given an unclaimed utterance, we have a couple of claimed utterance candidates, and we pass the first step, the role collection containing the word level similarity. Meanwhile, it's the JCAT similarity. And another one is calculate their semantic similarity. The semantic similarity between the unclaimed utterance and the claimed ones are using their pre-trained BERT embedding, the sentence level BERT embedding plus the face model. So that's calculate their semantic similarity. And another part of the paraphrase detection is from the paraphrase matching. We train a seamless network on claimed utterances and then to detect the utterance pairwise relationship. That's from neural network side. We use for each unclaimed utterance, we calculate their pairwise similarity for all the claimed utterances, and then we select all the claimed utterances with matching score. The matching score including the role selection score plus the pairwise matching score, and only the claimed utterances above the threshold will be used as will be counted as a paraphrase candidate, and that will be used for the skill retrieval part. And in the skill retrieval system, it contains, as I mentioned, two steps. First one is shortlisting, and second one is a re-ranking. The shortlisting is because we have too many skills to recommend. So if we directly put in, sort them and select the top K skills from thousands of the skills, that will be a bit difficult. So we use a shortlisting stage, which is a TF-IDF model, to first filter out the best match skills in a smaller scale, and then to construct the shortlisting skill candidates, and then we will pass to a re-ranking model. The ranking model is shown in the right. The re-ranking stage model includes the original utterance and the top K paraphrases, and also the shortlisting skill sequences calculated from the shortlisting stage. And they will pass to a encoder, a BERT encoder, to calculate their representation, and pass to a BioSTM module to predict the sequential labels for each utterance and the paraphrase. So besides the loss function, besides the original cross entropy function, cross entropy loss, we add a label alignment loss, meaning to minimize the prediction scores KL divergence on the skills with positive labels in paraphrases, but not in the original utterance. So this is the extra loss we add to make to help to predict better label sequence. That's like a soft data augmentation step. So the dataset we use containing two datasets. One is from the ENUS, and one is from the ENCA. Those are unclaimed English utterances from the devices in the United States and Canada. The third, there's another third dataset is for the claimed English utterances. So we generate the claimed utterance dataset from the devices in both countries. And in the end, we have 1 million unclaimed utterances, 80,000 unclaimed utterances in ENCA. For the paraphrase detection evaluation, so with the paraphrase detection, in the first step, we evaluate different encoder structures, such as tiny bird, bird, and so on. And we show the comparison results here. So this is for the encoder structure to build up the seamless network. And in the end, we find that the IMO structure surprisingly performs the best. The second one is the skill retrieval evaluation. So in the skill retrieval module, we have multiple components. So TF-IDF is for example, TF-IDF is for the Elasticsearch. Listwise is for the BioSTM layer, and the listwise plus PL is how we calculate those. So those are the truncated parts of our full model to see. By removing each of the module, we can see whether they will cause a model performance degradation. And in the end, we find that all the model parts in our designed model are useful, and we evaluate on the precision recall F1 score and the NDCD. And in the end, we also there are lots of the parameters we can tune, such as the row selection number, paraphrase matching threshold, shortlisting skill length, and paraphrase number. So we tune those parameters and find that the larger value on those parameters overall has a better performance in the end. And that's all. Thank you.